exposition.
So today's video is about energy, which is appropriate because two of us are still sick. And
Woo! Energy!
So here we go.
What is it? Well, it's simply the capacity to do work.
What is work? I forget what work is.
Remember, that's when you have a force moving over a distance.
So you got to have
okay.
force and distance.
Right, and energy is what allows you to do the work.
Okay.
Cool.
And it's necessary for any change to occur. So if you don't have energy, you're really not going to need changes to occur. A few examples would be like a change of position, so moving from one place to
Changes
another.
that you need energy for, right?
Yes, that's what
Yes.
causes the change. Yep, having that energy. And so you can change your temperature, you can
Up or
change
down.
your shape,
Yeah.
which is a little odd, but you can change your shape. You can
Well,
change
like if
your
you have
chemical
Play-Doh, it
composition.
takes energy to...
To
That's
deform
true.
It, or if
That's
you get in
true.
a car wreck and
Or
the
what-
front of your bumper gets crumpled or stuff like that.
But then it comes back all fixed.
It
so
does.
changing chemical composition, so like a chemical reaction, definitely going to be a
Yes.
energetic state, either going in or
Chemical
going
change.
out. So the big thing is you have to remember that all matter contains energy in
So
some
pretty much
form or
everything
another.
With mass
Yep.
and
Because even if you get down to the
substance.
smallest little thing, those little molecules, they all have it. Even a solid, because those molecules are vibrating back and forth slightly. You can't see it, but they are. That's their energy there too.
Okay, and I'm guessing we're going to go through all those forms of energy that...
Yeah, absolutely.
Indeed.
Just remember, guys, it's not electricity. Electricity is not specifically like there's not electricity in everything.
Right.
Energy is different than electricity.
Electricity is a type of energy.
is a
we
type of
can easily
energy,
put it.
but it's not
Yeah.
the same as.
The reason they point this out is like, you know, some people sometimes refer to the electric company as the energy company, but there's way more to energy
Ex-
than...
Yeah,
Exactly.
exactly. So let's look into that.
So, and one thing to remember, the unit for energy is the joule, that big J. So, which was the same thing that was the energy, or the unit for
Work.
work.
Yep. So you can
Nice.
see how they're related.
All right, so the first type of energy is mechanical energy. What'd you say?
I was just saying there's 5 types.
Oh, okay.
Mechanical energy.
So mechanical energy is energy that is released by the motion of an object, okay, or drives the motion of an object, right? So
Cool.
if I take this mouse and I'm moving it, that's because I'm putting...
Mechanical
Mechanical
energy.
energy.
Your
Shoot
arms
Nerf
moving up
darts,
and down.
throwing a football,
Yeah, little
crumpling up
wind-up toys
paper,
use mechanical
chewing
energy
gum,
to move.
Yep.
all that
Basically,
kind of
if it's
stuff.
moving, it's probably got
It's
some
moving, it's
mechanical energy
mechanical
going on.
energy.
My
Yeah.
mouth's moving because it has mechanical
Yeah,
energy.
Yep.
air is moving.
Yep.
All right, heat energy. Remember now, the heat is energy that is released, and this has to do with the internal motion of particles. So it has to do with the vibration of particles in that. And if we're going to talk about the vibration of particles, we got to talk about 3 states of matter. What I want you guys to get out of this is that gas, of course, as we said, there's spazzed out molecules. It has the highest energy.
Very
More
scientific
heat.
terminology.
Yes.
Yeah,
Spazzed
spazzed out. Well,
I use
hey,
that all the time.
Exactly. It's a very scientific
You don't
term.
learn that till college.
Liquid, less spazzed out, aka kind of medium speed if you're going to compare it to solids, which have the slowest molecular movement.
Yep.
And gases, again, would having the top, so liquid would be in the middle.
And remember, solids do have motion. They're vibrating very, very slowly.
Yeah.
Theoretically, the only way you could have no motion would be absolute zero. Although
Yeah.
they actually theorize that's impossible to do. So
Yeah.
So what would happen is you add heat energy to something, it gets more motion.
yep, they
Yep.
move faster.
And you start to go from liquid solid to gas.
And the reason the solid turns to a liquid, like if you have an ice cube, is because
Yeah.
those molecules start vibrating so fast that they come apart enough where it turns into a liquid.
Yeah.
Yep.
Yep.
Ooh, chemical energy.
Hey,
Awesome.
your favorite.
It's involved in everything, right? So it's the energy released when it.
Sorry.
It's the energy released when atomic bonds are broken or formed. So the whole idea behind this is you have any chemical reaction where you take a molecule, boop, splits apart, boop, goes back together. You've got energy being released or put into it. That's all chemical energy.
So-
it's the result of gaining or losing or sharing electrons.
So where is the energy stored? Where's chemical energy stored when you have a when you have
I'm
food?
glad you asked. Mr. Harkins, do you happen to know, or would you like me to field this one?
Where chemical energy is stored
Yeah.
in a magical place called the battery. Oh,
Ooh.
wait, no. You're talking ATP inside our bodies.
Right, bonds. It's all
Yeah,
in the bonds.
Chemical bonds, yeah.
Bonds, chemical bonds.
Don't eat
So
batteries,
every
kids.
single one of these
Double
little
O zero.
lines in this molecule stores energy.
Yep.
Okay. Energy is stored between those two. But okay, we'll get into that. when
Yeah,
we go into bio.
exactly. I was going to say.
You'll hear all about that. All right. Anyway, so is it my turn? Electromagnetic
Sure.
energy. This is energy, light. Okay, emitted by excited electrons.
Woo!
So
And that's what
yeah,
that's what
That's pretty
gave us
much
when we
it.
talked about the electromagnetic spectrum.
that's energy we get from the sun.
Yeah.
The reason why it gets hot is because don't mind me. We're gonna get into conversions here, but light energy comes down. It hits a surface. And then it converts to heat energy.
There you
Yeah.
go.
Maybe you could convert energy. Maybe we'll save that for another time.
Yeah, we're going to do some activities in class on that too with changing energy types and things like that. So, All right,
Tell me.
nuclear
Ooh,
energy.
I
The
wanna-
energy of the nucleus of an atom is basically it's released, you guys, when the bonds that hold the nuclei of the atom together. Remember the center of the atom when those get broken or created. So either fusion or fission when you get these things. That happens inside the nucleus. So we're not talking chemical bonds between stuff. We're actually talking inside there.
So like the protons and the neutrons.
Probably would
Yes.
help if I put up all the definitions.
Yeah, no,
Yeah,
that's
it's all
fine. Fission is when it actually fizzes, when you get a fissible event and it splits. So when you hear them talk about splitting the atom, they're talking about when the protons and neutrons break apart. They separate from each other. And fusion would be the opposite of that, which is when they fuse together.
True.
So, and
So here's a Simpsons joke.
Yeah.
Mr. Burns, the guy who owns a nuclear power plant.
Yes.
You know what the name of his boat is? The
gone fission.
The Gone Fission.
Yeah, gone
Oh,
fission.
that's right.
Yep.
yeah.
Yeah. The Simpsons.
Moving
So,
on.
All right.
Sides jokes.
So okay,
It's good.
there's in addition to all the different 5 types, there are 2 main forms of energy, and the first one is potential energy. And the term potential means you have the chance that you could do something. Or you
Yeah.
have
The
there's that
potential to do it. It
do
could possibly do this.
So basically, potential energy is stored energy. And this could be anything where you could simply have a spring compressed, you push it together, it has all the energy stored into it. If you let it go, it potentially could go boing. Ninja getting ready to strike, always awesome. Ball on the edge of a desk. The bonds in a chemical reaction, that's potential energy stored in it also.
Yeah.
Okay.
So basically, matter at rest, when it's not moving, has potential energy.
So you mean to tell me my mouse right now has potential energy in it?
Yes.
What does the word potential mean anyway?
Potential means that it has the chance too, that there's potential. that
capacity
there's
to
the
do it.
capacity to do
Even
something.
even in non-science terms, potential means you can do something, right?
Yeah,
Yep.
exactly.
So this means, how would I release the potential energy of my mouse?
Drop it.
Can I slap it out of your hand?
Woo!
Aw.
Good.
I mean, I wasn't gonna drop it on the floor. Oh,
Ooh.
or I might.
Possibly almost.
Now, when something starts moving, it has what we call kinetic energy. Okay. So something that has potential energy, if you drop it, that energy gets converted into kinetic energy.
And we were going to talk a lot about that, about when something has kinetic energy, when it has potential energy, and we're going to touch on it just a little bit here.
Yeah. So so your basics are stored energy,
Potential.
Potential.
energy being used and
Yeah,
moving.
the
that's
motion
kinetic, yeah.
energy is
Kinetic.
kinetic.
Yep.
And kinetic literally means motion. Kind of like those pictures of the pendulums here, and we will have at least one set up in the room and do some little experiments and demos with our own pendulum in the room. But you can kind of see in the illustrations there, it's basically a ball hanging on a string.
I'm mesmerized.
And we have an illustration on your notes I'd like you guys to fill in. At the highest point, we have the abbreviations there, PE and KE.
This means pendulum. This picture's of a ball on a string.
Yeah,
so
we should explain
like,
that.
This right here is step 1, step 2, step 3,
It's the
step
ball
4, step 5.
swinging
We're basically taking
back
a ball,
and forth. Yeah.
kind of like someone's on a swing set. You're holding them up. You're
Yep.
gonna let them go, and
They just
see
swing
what
back
happens.
and forth.
So at the top,
At the top, potential energy is the highest.
Okay.
Because it's not moving, but it's got a lot of potential energy because gravity is really getting ready to pull down on that. We haven't released it yet. The kinetic energy is at a minimum. It's like basically 0 because it's not moving yet.
Right.
But as we release it, you start to see a conversion there where the potential energy starts to get smaller because a lot of it now is kinetic energy.
Yep.
And it's moving. It's on that downward arc. And when we get right to the bottom here on this next part, you can see that potential energy now at the very bottom is the minimum. It's at the lowest point. It doesn't have a lot of potential energy, but almost all of it has turned into kinetic energy. So, and then we're going to kind of see the same thing as we go back.
out.
as the
Opposite
ball
happens when it goes
swings up, I think
Yeah.
I'm going backwards on here, but as the ball swings up, it loses kinetic energy.
Yes.
Gains
It's
potential.
going upwards,
energy.
but it gains potential energy.
Yeah,
Kind
so
of like
it's
if you
getting-
throw a baseball into the air, as it goes higher up, gravity starts working on it. Potential energy.
Yeah.
It has more potential energy. It loses kinetic energy. It moves slower.
Yeah.
And finally, at the top once again.
It's just like where it started off again. It's its highest point, and it's no longer moving.
Right.
It's got potential energy. It's maximum.
Yep.
Kinetic, it's not moving, so kinetic energy has to be low. Whenever it's not moving, kinetic energy is low. When it's moving really fast, kinetic energy is going to be higher.
Cool.
Cool.
I think
Alright.
that's it.
That's
it.
energy.
Do your checkpoints, guys. We're going to do some cool stuff in class relating to this.
Do your checkpoint.
Bye.
Bye.